Hello everyone! For this video, we will be talking about experiment number 10, entitled Determination of Optimal Moisture Content by Standard Proctor Test. The Standard Proctor Test is one of the standard methodological experimentation that is used to conduct and determine the compaction characteristics of a specific soil sample, wherein this enables to attain values and the several characteristics in accordance with the similar moisture contents of the soil. In the field of civil engineering, stability is one of the major components or factors that is significant to be considered in dealing with load capacity and stability, wherein the Standard Proctor Test is also responsible for determining the following factors that affect the stability and the load capacity of the soil, in which the optimal water content and the maximum dry density is attained through this specific methodological investigation. The optimal water content of the soil simply refers to the idea of the moisture content in regards to its corresponding maximum dry density, whereas the maximum dry density refers to the aspect of the highest recorded dry density of the soil in regard to its corresponding optimal water content. The objectives for this video experiment is determine the percent compaction and molding water content using the Standard Proctor Test. Scope. These test methods apply to soil materials that have 30% or less by mass of particles retained on the 3/4 inch sieve and have not been previously compacted in the laboratory, that is, do not reuse compacted soil. In relation to the standard test method of Proctor Test ASTM D698, is the basis of the standard methodological process, wherein this is entitled as the standard test methods for laboratory compaction, characteristics of soil using different effort.
These were the materials used in conducting the experiment: compaction rammer, number 4 sieve, mold assembly, rubber mallet, metal pan, straight edge tool, trowel, soil sample, water, weighing balance, and graduated cylinder. The first step for the methodology is the representative soil samples were taken from the source soil. Second one is to prepare the soil sample. It was air-dried till the material became friable. Soil sample was then pulverized using a rubber mallet. The soil was then sieved through a number 4 sieve and a coarser materials were discarded. Approximately 3 kilograms of air-dried and pulverized soil sample were taken. Water was then added to the sample. To find how much water should be used, use the formula water in ml is equal to mass of soil in grams times 8 all over 100. The formula used is for the trial where the soil has 8% water content. The mold was cleaned and its dimension, which is height and diameter, and weight with and without the collard were measured. The mold was put on the base plate with the collar in place. Soil was added into the mold and compacted with 25 blows of the rammer. The collar was removed and protruded soil parts were trimmed using a straight edge to level the mold top. Then, the soil in the mold was weighed. After weighing, the soil was removed from the mold and broken until no lumps remained. 5% of some additional water were added into the soil mass to further elevate the moisture content. Steps 7 to 10 were repeated till the moisture content exceeded the optimum water content, thereby reducing the soil unit weight.
In this section, This illustrates the values that are attained before the proper test procedures, in which these includes the measurements of the modes, the mass of the soil, and any other significant values that are needed for the whole methodological experiment. One of the significant parts of this method is the formulas of the bulk density and the dry density, in which the bulk density is obtained by dividing the mass of the moist soil of the succeeding water contents from the total volume of the mode. On the other hand, dry density is also obtained by dividing the bulk density from the water contents of the sample plus 1. Doing a standard Proctor test of soil will help to visualize and determine the optimal water content that propel in getting the maximum dry density. The gathered data above showcase a calculated bulk and dry density of a soil sample in every 5% interval of adding water starting from 8% of its total mass. As the water content increased its volume until the 23% mark, the mass of the soil sample also went in an upward trend as it underwent 25 blows each trial. The value of the sample's dry density is 1.0396 grams per cubic centimeter by following its formula, which is the quotient of bulk density and the sum of water content and the value of 1. As the added water in the soil reached 28%, the moist soil started to lose its mass. The 33% mark is a solid indicator that the maximum dry density was already attained, for it continued the downtrend pattern in its mass. By having this kind of result in the experiment, the maximum dry density was determined at the point the soil has 23% water content of its original mass. It also met the desired results of the shape of a compaction curve of a compaction test of a soil that is expected to be parabolic in shape. Its vertex point is the maximum dry density by having an optimal water content.
The experiment conducted is the determination of optimum moisture content by standard Proctor test, where its importance is to investigate the moisture density relationship of the soil. In the field of civil engineering, stability is important when it comes to dealing with load capacity and strength of soil. This experiment will tackle the behavior of compaction characteristics of soil when the moisture content increases. ASTM D698 was the standard that was followed in doing the experiment. The experiment's objective, which is to determine the optimum moisture content by standard Proctor test, was achieved. Based on the data and results, the maximum dry density, which is 1.0396 grams per cubic centimeter, was determined at the point the soil has 23% water content of its original mass. The desired result of a graph with parabolic shape was also met. In conclusion, as the moisture content of a soil sample increases and compacted, there will come a point where it reaches its maximum dry density, and that point is also its optimum moisture content. As for this experiment, its optimum moisture content would be 23%, which will then result in a maximum dry density of 1.0396 grams per cubic centimeter. Increasing the moisture content of the soil sample will only result in a lower dry density, which is also an explanation why the graph has a parabolic curve. The vertex of the graph is where the optimum moisture content is located.